going to focus on, go back to the IP version 4 for now.
Yeah.
Talk more about, the IP version 4 and in some, aspects and some details, so we can understand better the IP version 6 layout and format. So, again, we have talked about, the IP version 4 classes. We said that we have 3 classes, okay, class A, B, and C. We have another like D, which is the multicasting address. Okay, so we've talked about the class A IP address, and this is the range is start from 1 up to 126. Then we have class B starts from range 128 up to 191. Someone will ask us, where's the 127? If you guys recall, that's the 127.001. This is a loopback. This is a reserved IP address that you're going to use just to test your IP stack configuration, if it's configured correctly in your machine or not. Okay? This is the IP loopback, which is 127.0.0.1. Okay? So this is a reserved IP address used just for testing locally on your machine. Okay, if you have a connectivity issue, for example, you can't communicate to the others on the network, you start by testing your local machine, pinging that loop. So you do ping 127.0.0.1. Okay, so if if you have reply back, that means your TCP/IP stack is correctly configured on your machine. So then you go to the next step of troubleshooting.
Does this cover like a printer or anything, or in the network?
Well, this is just a local machine test. Any node that has that IP address, okay, you can, especially like particular laptops, desktops. Okay, so if you want to, because when you assign IP address to your machine, okay, there's like a field that you go on Windows, you go and you do like a static IP address configuration. So you assign the IP address, and then you assign the subnet mask and the default gateway, and then there's like a field for DNS servers, right? So once you apply all these settings, okay, the IP address is already now configured on your machine, and it's ready to be communicated with others on the network, right? Now, if you have a connectivity issue, right, you start with pinging your local stack, which is the loopback. It's like a loop, so you're doing like looping in your in your machine. You know what I mean? Yeah. So that particular IP address, 127.0.0.1, give you a looping task. So you ping, you send, like if you're sending a packet to your machine, and if you get a reply back, that means your configuration settings on your machine is correct. And then you go to the next step of troubleshooting. Okay? So that's why we have a 127 here. It's reserved for loopback. Okay?
When something wrong, let's say you configured something wrong, what kind of message do you get?
Usually it will tell you, something, stack, TCP/IP error, configuration. You will see it on your machine. Okay. Usually. Or you might not get any messages. You might just not able to communicate.
Okay.
Basically, yeah. It depends on the operating system if it's going to generate an error. If it's parsed to generate an error for a configuration IP address.
Oh,
yeah.
Okay.
So now we have class A again. Now class B, as I said, ranges from 128 to 191. And then we have class C, 192 up to 223. And then we have the multicast address, which is start from 224 up to 239. Now the multicast address, we've talked about multicast addresses. Now we have a reserved block of IP addresses. These are multicast IP addresses used for multicasting. It can't be used for anything else. Multicasting, we've talked about multicasting before. We said multicasting is like one-to-many communication, right? So it is, Assalamu alaikum. So I'm not one node here, to many. So this is one to many communication. This is what multicasting means. So I have a packet, okay, I'll send it to a group of nodes on my subnet. Could be in a local subnet, could be in a different subnet. Okay? So, and we have other, type of communications we talked about last time. We talked about like unicast. Unicast is a one-to-one communication. Okay? I have a packet, I'll send it to this destination. This is a one-to-one communication. Okay? And we've talked about another type of communications called broadcasting. You guys hear, this term, broadcasting. It's a common term used actually in the IP communication. Used to, okay, I have a packet, I'll broadcast it to the whole node, to all the nodes on the same local subnet. Okay, I have a subnet of like 10 nodes, I'll send that packet, everybody will get that packet. So what's the difference?
One to many?
Okay, yeah, it's one to many, but it's, for broadcasting, it includes everybody in a local subnet. For multicasting, it's one to many, but the packet is this time, it's, the destination is like a group of nodes in that subnet. Okay, so here. For example, I have this subnet. This is one node. This is another node. Okay? So, for example, this is the source machine. I want to send a packet. Okay? I want to do broadcasting. So this is the packet that I'm going to send. Every single machine here on this subnet, just one local subnet. Every single machine on this local subnet will get that packet. It doesn't matter if I'm the, the correct destination or not. Everybody will get that packet.
That's
now,
the broadcast.
That's the broadcasting.
Okay.
Now, multicasting is more efficient kind of communication. Because, okay, I want to send this packet, but I don't want to send it to everybody. I want to create like an overhead in my network. I don't want everybody to get my packets. I just want to send it to just a group of people. Okay, so I'll send this multicast packet to just this guy and this guy. Okay, why send it to everybody? For example, you will need, in IP communication, you will need sometimes just to send it to a group of people. That's called multicasting. So, just give it to group
Mel
people.
was referring to multi or to broad?
Okay, now, communications in the IP version 7, there is nothing called broadcasting. So that's another difference between IP version 4 and IP version 6. IP version 6 doesn't deal with broadcasting anymore.
Oh, okay.
Okay?
Which is
All the communication is either unicast, one-to-one, or anycast, or multicast. So they use multicast a lot in IP version 6, and they use anycast communication. Anycast is, you send it to the, it's like a redundant connection. You send like a packet to different kind of, for example, here, the anycast, what the anycast means. Okay. I have this machine, okay, and I have this router here as my default gateway, okay, and I have another router. So for this machine, he's going to send an anycast packet. So anycast packet means it's going to send a packet to this router, and another replica will be sent to this router. So for example, if this router fails, okay, I still have another packet, so it will give me up.
So it's just like a broadcast.
It's not a broadcast. It's a broadcast, but it's a different version of broadcasting. It's completely different in the IP version 6 world. Okay, it's more efficient because when you send a packet, you send it for a redundancy purposes, not for just I want to send this packet to everybody and create like an overhead in my network.
So what is the purpose?
It's the closest.
But what's the purpose of doing redundance?
Redundancy, you need redundancy in your network. Always, when you think design, you need to do it redundant because otherwise, you don't want to like have a point. You need always to have like a multiple path to a destination. So in case of a path failed, you still have another path to that destination.
To the same destination.
To the same destination.
Okay.
Yeah.
What is that called?
Anycast. Anycast.
Let's say.
This is we're gonna talk about for when we come to the IP version 6.
Okay.
This is particular for the IP version 6. This does not exist in the IP version 4.
Yeah.
Anycast.
Let's say you have 3 routers will send another packet to the
No.
third one, or just the closest?
The closest.
Okay.
See, so it's more efficient communication.
Yeah.
So it's send it to the closest.
Because the broadcast, it will send to everyone.
Right,
Yeah.
exactly. Multicast, it will send to a group of people.
Yeah.
Like, you know, these guys, for example, or
Yeah.
these just two.
So how do you like specify which one
Closest?
goes to the
Group, okay, that's, you know, we'll talk about later. Yeah, this is, you know, okay, now how you do that, okay, by specifying the IP address. So if you start your IP address with 224 up to 239, then you are using a multicast in this case. So, for example, this is 224.0.0.5. Everybody on the network will understand that this is a multicast. So this is a multicast group. So a group of people, okay, whom configured to be a multicasted group will understand that packet, not anyone else.
Okay.
But can
Okay.
we can see what you wrote down.
Okay.
I-
For example, this is a
No, this is
multicast
good.
app, yeah.
I'm,
Yeah.
I'm talking about
Right.
when you said there is a multicast starts with 224 to
Up
all
to
the way
239 now.
Okay.
This is a class D and reserved for multicasting addresses. Okay?
Oh, I thought that one for the government or the army.
No, this is from 240 up to 254. This is for the reserved block. They're يعني for research and development things. So they're not much. Okay, these block for IP addresses start from 240 up to 254. Okay, so from now on, whatever you see, any IP addresses start with this range. Start from 1 up to 126, you gotta know that this is a class A IP address. If it starts with 128 up to 191, this is a class B. 192 to 223, that's a class C. Okay, this is what we need you guys just to focus on for now. And then
This is only for IP.
version 4.
Okay.
Correct. Because, you know, as we gave you guys like a brief last time, you know, IP version 6 is completely different.
Completely different.
Format, different headers, different mentality. You know?
Yeah. They don't divide it into A, B, C. They don't IB6.
No classification like that, no.
No
Not
classification.
version 6, no. Because, as I said, I mean, in the beginning, IP version 4 is 32 bits. It's 4 octets. Each octet is 8 bits, right? But in IP version 6, it's completely different. 128 bits. Okay, and they use like a hexadecimal, letters and numbers combined together to represent that IP address in version 6 or next generation. So, but I mean, I need you guys to understand IP version 4 first. So for you guys to be able to understand a little bit, you know, IP version 6. Otherwise, it's going to be tough
Yeah.
for someone who doesn't know exactly what the IP means. Okay. Now, let's just move out to the private IP addresses. Do you remember, guys? You know, if you guys recall, we talked about the private IP addresses blocks when we talked about Class A private IP addresses, and Class B and Class C. We talked about the Class A private IP addresses start from 10.0.0.0 to this IP address. So any IP address lie in this range here. This is a Class A private IP address. So, for example, let's just get this IP address as an example. 10.0.0.1. Okay?
Right.
This is a private IP address and a valid IP like Class A private IP address. Why? Because it lies in this range. Okay? You see this? It is lying in this range here.
So when we see number like IP address, we say this is a private network.
Private IP. It starts with 10, okay, and it goes in this range. So this is a Class A private IP address. So if you see another one start with 172.16 and then another number, okay, then that's a Class B private IP address.
So is it the first number that has to be 10 or 172?
Correct.
The rest you can change?
Exactly. So this one, it has to be 10 at the beginning,
Okay.
and then
You
see,
can change.
zeros. What does zeros means that you can fill in any numbers up to 255,
Oh, okay.
right? That's what it means. Why 255? As you guys recall, because there are 4 octets. Each octet is 8 bits. So when you do the calculations, 2 to the power 8,
It's
it's
255.
256 minus 2. That will give you how many usable IP addresses for that user. So you can't
Why
go
2?
beyond 256 in IP communication.
Okay.
Okay.
Why 2, ya
So-
shabab? Why 2? 1,
One is reserved, isn't it?
1 the loop back.
And then one is instruction 0.
Okay. Why you get like 2? Now this is. I'm gonna talk about something else here before we talk about why it's 2. Why we're
But briefly,
back to
like,
2. Yes. Okay, let's just move, continue. 172.16, and then we have class C here. Start 192, 168, and then zeros, and then up to. So you put
192, 168, 00.
exactly 00. So if you see this IP address, for example, this is a common IP address you guys will see a lot because most of you using Comcast and
exactly.
DSL, whatever. So this is usually the IP address that you guys get from your provider. So it'll get you if you go and do. How do you guys check your IP settings? You do what? IP config. Okay, IP config. This is the main command. You do IP config in your
DOS.
CMD, your DOS command prompt, and then you type IP config. It will get you your IP address.
Now they have some
configuration.
websites. They
Slash
can
all, it gets you the MAC address and more details.
No,
So-
no, no. What is my IP?
Exactly. So, if you check your IP configuration, you'll see in your home 192, 168, usually .0.1, for example. So this is a Class C private IP address. Again, the private IP address, these IP addresses that you can use in your local network. These are not routable IP addresses, so you can't use them outside of your local subnet. Okay? So if you need to communicate outside of your network, then you have to have what? A NATing device to translate the private IP address to public IP address.
Like what? What is a NATing device? Like what? There is a device called NATing?
NATing or firewalls.
Oh,
Pretty much
firewall.
the same.
Okay.
It's either a dedicated NATing device from Cisco or firewall. Firewall does the same, functionality of the NATing device.
Have you heard of a program called TeamViewer?
Team?
TeamViewer.
Yes.
Yeah.
How does that work when it comes to letting people into your, connect to your IP?
To connect to your IP.
Well, to connect to your computer, doesn't it go through your IP?
The
Because
desktop
it's-
remote.
It's
Like the
all
desktop
under
remote.
remote desktops,
Remote
protocol. Yeah, exactly. I mean, you RDB into someone's machines. I mean, you don't have to have a third-party application to remote into anybody else's computer. If you guys are on the same network and you have RDB on your machine and somebody else have an RDB, you guys can communicate through just regular Windows. Yeah, you go remote desktop and then you put an IP address of your destination. It'll be connected right away. Now, we have a lot of remote desktop applications. Remote assistance from Microsoft or
Yeah. My PC.
My PC, connect to my PC, or log me in, or...
But if you're not in the same network,
If you are not, what?
in the same network,
If you are not in the same network, then you will have a different third-party
What do you mean?
software.
Let's define you're not in the same network. Hassa, I could be home, went to you be your house. أنا وياك, if you have a team viewer, I could log in on your computer.
okay.
What do you mean in the same network?
No.
No, what he means is not in his, in a local network.
Yeah.
He meant.
Yeah, like when,
Yes, if you are not in a local network, okay.
let's say you're in New York, I'm in Florida.
You can't
We're not in
RDB.
the same network.
Yeah, you
No,
can't.
no, network has nothing to do with geographically where you're at. You could have a same network, Saudi you have. That has to do with the IP address. So we're talking about when you say using one network and I using my own network, that's totally different. When you do
Can you
team
define
view-
that? What do you mean when you have your
Let's say you want to use your own network. When he's referring to a network, let's say أنا at home, I have my own network, I have a
you have your own
printer,
router, right?
I have a printer, I
Okay.
have a few computers, they all in the same network.
Network, exactly.
But anyone outside my network, that's totally different network. So we're not on the same network when we are on TeamViewer. But I don't know how they do the connection. I think IP to IP.
Yeah, well, yeah, and I got his question. Yeah, that's yeah. When you're communicating outside to the internet,
Yeah.
it goes through tunneling and it goes through your service provider to connect you to somebody else. You know, and it goes
Oh,
through
yes.
like a complex communication for you to be able
Exactly.
to log into somebody else's computer.
Yeah.
But it can be done.
Oh,
You
yeah.
know, but we're talking just locally. You know, locally you can just use your remote desktop. You go to your remote desktop and you know just type IP address for the destination, and then you're in. Yeah.
Quick question, Ahmed. Let's say I'm building my own network at home. I have a printer, I have 2 computers, I want to put them all on the same network using 2, 3 computer printing from the same printer.
Yeah.
And I have a gateway where it takes me outside.
Correct.
So I'm assuming the private IP, I shouldn't give any private IP to the gateway.
You need to give it to the gateway.
Yeah, gateway. Do you give it a private IP or?
Yes.
Public,
No, gateway usually it's a router. Okay. So your interface. Okay. For example, the router has like a local interfaces here, fast Ethernet, where it is connected to your local.
Yeah.
So here you assign an IP address locally.
Yeah, but the
Your
other
network.
side,
It's gotta be understood as globally. For example, if you're connected to your service provider, okay, AT&T, Verizon, whatever, they will give you a block of IP address that match their IP address. They're in the same subnet. So usually this is what called the customer edge CE router, customer edge router, okay, and the router that's here is usually called the PE router, which is the provider edge router. So these routers has to be on the same subnet. So they will give you an IP address. Okay, this is my IP address that I'm going to use. You should be in the same subnet as mine. So they will give you a public IP address, okay, but they have to be at the same subnet for them to be able to communicate. So Sammy, this is a local interface IP address. You assign it to the local.
yeah.
And this is an IP address, a public IP address that is assigned to you by your provider to be able to communicate with your provider, and from there he will take you out.
Okay.
Okay? Through their network. They have a complex network that go, for example, MPLS. It's a mesh topology. A lot of MPLS servers, MPLS routers, that routes your packets. Your packet, it goes through like maybe many, like 100,000, hubs in their network before it go out to the internet. So yeah. Okay. So now, so far we're good with like the classification, class A, B, C, and then the private IP addresses. Now, private IP addresses used locally. We talked about public IP addresses. These are the IP addresses that you use to communicate outside of your network to the internet. Okay? So any IP address that does not lie into these ranges, consider what? Public IP addresses.
Which you
So-
cannot assign, right?
Exactly. So 151.20.31.1, this is what? Private or a public IP address?
Public.
It's public. It does not start with 10, it does not start with 172.16, it does not start with 192.168. Then this is what? Public IP address. But what? Class B public IP address or Class C or Class A? It's 151.
That one's a class B.
It's Class B, exactly. So this is a Class B of public IP address. It's not private IP address. Okay? So what about this, for example? Let's say,
199.
exactly, 199, for example, dot 31.51.2. This is what?
This one is class C.
This is a Class C public IP address. Okay? So these IP addresses used to, to communicate with the outside, to the internet. Now I just want to talk about like something.
I have a quick question.
Go ahead.
So the private address, you know, like Sami said, you know, if you're connecting your printer, you're connecting your fax machine, you're connecting, you know, like other two laptop, you can choose the number, right? Like you can assign the number.
Yeah, you are free to use
But
any...
the public, you
Uh-huh.
can't.
Exactly.
It's just given to you.
As we talked about, like in the the previous class, the public IP address, these are block
But-
of IP addresses usually signed by your provider
Provider, okay.
to people to be able to go out. You know?
Okay.
So, and
Which is statics.
exactly, and there's an organization called IANA. This is what controls all the IP addresses management in the world. So
Okay.
it gives, you know, IP addresses to these providers, and the providers will give it to the companies, organization, or sometimes to people. You know, because sometimes, you know, people, they do look for global IP addresses to communicate outside.
Can you purchase a public IP address, like permanent purchase?
Yeah.
No,
Yeah,
not
you-
renting, not pay monthly, like buy it, it's yours. It's
Yeah, yeah. Well, that's what the companies do usually. They, you know, buy them permanently. You go, you talk to your provider, and they will, okay, you know what, you have a company size, whatever, you know, 10, 15 people, I'm gonna give you a block of IP address from one, whatever, you know, I'll give you maybe 15, 20 addresses.
But this
Yeah,
is
and you
it's
pay
like,
for them, and yeah, monthly. Or maybe sometimes,
so 20 is about like $200 a month.
I don't know exactly how much does it cost, but usually per IP, I think $5 to $10, something like that. But if you do like back, like a block, it might be a different calculation for them. Yeah. Okay. So now we're gonna talk about, you know, the network and the nodes. So now we understand the format of the IP address. For example, 10.1.1.2. Okay, this is an IP address. This is a class what IP address?
Class A private.
Private IP address, exactly. Okay. Now, for class A, 10.0.0.0, this is what? This IP address called what? It's called a network address. This is the network address. This is not a valid IP address that you can assign to your machine, for example. So can you assign this IP address to your machine,
You
to
have
your
to add
laptop?
one, right?
Huh?
You have to add
It has
one.
to be at least one.
At
Not
least
just one. This is reserved for your network, so you can't assign it to
Just
your,
like a name,
a
right?
node. Exactly. This is not a name. It's just this is your network. This is where your network starts from 10.0.0.0. You can't give that IP address, assign it to a machine. It's not going to communicate. It's not going to work. So this is for class A. This is what defines your network. The first octet here. Okay, that means this one must be 10. Okay, the remaining I don't care. You can assign it to any nodes. Okay, and you can add, like, fill in these numbers, whatever numbers you want, up to 255, 255, 255. That's it. You can't go, as we said, you can't go beyond 255. So this is, for example, 10.1.1.2. So this is a valid IP address. 10.0.0.1, 10.0.0.2.3. Okay, so you go and you can assign up to how many addresses?
255 in
8,
each. Yeah.
8, right? We have 32 bits, 4 octets, okay? So we said this we're not gonna touch because this is represent the network side, right? So what you can play with these. So if I wanna know how many nodes I can assign into this network in the 10 class A private network, then what you do, you go and you do 2 to the power
Wait, 3,
24.
24.
Because you have 8, 8, 16, 8, 24. So 2 to the power 24, if you calculate it, it's going to give you probably over 65,000 something IP address that you can generate from this network. Okay? So if you have a huge organization, and you know that you have a lot of nodes in your organization, so you're going to go with, most likely, with a Class A private IP address. This is what most of the companies do. So go with this one because it's going to get you up to 65,000 IP addresses that you can use in your network without any issues, without any duplicate IP addresses, without any problems. Right? If you have like a small size, you go with what? Which block? You go with Class C, right? Because Class C now, 192, 168, right? And then, for example, like 1.0, right? This is what? Class C IP address. Now, for this, you can fill in any number, right? Because it's 2 to the power a, like 8. So how many IP addresses is going to generate from that one? So 256.
255.
If you calculate 2 to the power 8, 256. You're going to exclude what? You're going to exclude 2 to the power 8 is going to get you 256 minus 2. So total 254 usable IP address. Why? Because you're going to exclude the network address. The network address, we will just talk, we can't assign it to any IP address, and you're going to exclude the last IP address, the IP address before the next network. I mean, it's called the broadcast address. Okay, the broadcast address, which is the following block of IP addresses for the following subnet. Okay, that one you can't assign it to an IP to a node on your network. So that's what you're gonna get from these ideas. 254. Same thing here. 2 to the power 24. You just minus 2. Always you do minus 2 because 1 for network you can assign it, 1 for broadcast address that you can use it as well in each segment. So you always exclude the network address and the broadcast address. Okay. So just keep this in mind. So this is a Class A. This is a Class B here. This is a Class C. Class B to the power what? 60 minus 2. Right. So this is a mid-size range block. So you can use it for mid-size organization. You know, because it's gonna generate you like how many ideas? 2 to the power 16 minus 2, about like 32,000 something. Yeah. Okay.
Question.
So do we have questions?
Do you think that when IPv6 becomes like extremely popular, that the reserved channels will free up, or will the government keep them either way?
Well, it's more popular, Maad, because the fact that you can generate infinite numbers of IP addresses from IP version 6 because it's 128 bits.
I understand that, but will they switch, or it won't matter?
What is that?
Is there any other benefit for them to switch over other than
IP version 6?
Yeah.
Yes. Now, yeah, they
The
do.
speed.
So
We've talked about like now. Okay, we understand now the IP version 4. Now, the first benefit.
No broadcasting.
That's one. Okay, you just mentioned we have no broadcasting. So that means what? Broadcasting is like annoying in your network. So you broadcast, everybody's getting, you create a lot of packets in your network going up like that, like between your sources and destinations. So you create so the broadcast slow down your network, creates a broadcast storm, something called in networking a broadcast storm. So when you have a lot of packets going in, in different destinations, so you create a storm in your network. And that slows down your computer. Sometimes it brings your network down. So you don't want to do this. So you eliminate the broadcasting in IP version 6. All the communication used either multicasting or anycasting, or unicasting, of course, if you're sending a packet just by a single host. That's one benefit. Another benefit, the header. If you guys recall, we've talked about header of the IP. Now, the IP packet is different from the version 4. It's different from the IP version 6 header. The IP version 6 header has less field, okay? While in IP version 4, it has a lot of fields there. So that means when you send a packet from a node on your network to, for example, another node, the router and the switch takes less time to process your packet. Okay, because the header is less. يعني fields في الheader is like much يعني less than in IB version 4. That's one thing. Another benefit you get from this, security. When you have a lot of fields in the packet, that means, you know, the hackers, they can take advantage of this and start, you know, playing with these fields, right? Flags, the offsets, the payload, the other, like a version. They can modify your header and your packet and your IP version 4. While in IP version 6, less fields, that means, you know, more secure for communication. Okay, so faster communication and reliable communication. Also, you're getting rid of the NATing device in IP version 6. Why? Because we have, as we talked last time, we have just link local IP address and a global IP address. We have no private IP address scheme in IP version 6.
What is it? One more time.
Link local IP address.
This is a new benefit other than the security?
Yes, right.
What is it called?
A link local IP address. This is يعني احنا هلا we start talking about the IP version 6, which is I didn't want to talk about now, but since he just mentioned the benefits of moving to IP version 6, so we're talking about the benefits why we're gonna transition to IP version 6.
I remember last time you said it's gonna, by like 2050, they'll run out of IPv4 stuff, estimate, but
Right.
do you think, well, are the bigger companies like Comcast and them, are they slowly moving?
So yeah, some companies they're moving, but as I said, I mean it's not a matter of just a shortage of IP addresses that they're, you know, scared of. Yani, there are other factors. The problem, the public IP addresses are poorly allocated in the network. That's what's happening. Yani, a lot of IP addresses, yani, the companies that go and buy them, they're not usable. They're just reserved for this company and they're not usable. There's plenty of IP addresses. يعني they can go with with IP version 4 up to 245 or 2050 with no problem. But they find that it's good, you know, to start planning and moving slowly to this. Even, you know, as I mentioned before, يعني هلا احنا دول الخليج they already started يعني IP version 6. Most of the companies here, they're still using IP version 4. يعني maybe 70 to 30%. Still IP version 4. Some companies they're, you know, already transitioned to IP version 6. هلا when you're talking about IP version 6 and mixed environment, IP version 6 and IP version 4, then you're talking about how you're going to transition here. How the IP version 6 packet is going to talk to the IP version 4 packet. It's completely different communication, right? Completely different headers and different packets. Here's, you know, they come with like a different solution for this, which is one of them, the dual stack routers. The dual stack routers that can be implemented in your network that understand both IP version 6 and IP version 4. So the interface itself, you know, assigned an IP version 4 and assigned an IP version 6 at the same time.
So if I try to
So
connect, if I try to connect the IPv6 with an IPv4 compatibility router, it just says no?
No problem. The interface and your router will get that packet. You will be able to distinguish if it's, you know, IP version 4 packet or IP version 6 packet, because the interface understands it, so he will route it to the right destination. So here's how it's going to work.
What if I don't have that kind of router?
Okay, we have another solution called tunneling.
Is it just the router, or maybe the device itself needs to be, you know?
Configured, you can configure it, and there is like a special routers that, you know, understand IP version 6, but I don't think more, you know, like a company will, you know, dedicate devices like this, you know, to be. Now the existing routers can do this functionality.
I'm saying like a laptop, does it have to have the capability of dealing with the...
Yes. I mean, you can assign IP version 6. See, in IP version 6 now, what happens in your machine when it boots up, for IP version 6 communication, the link local IP address, which is almost equivalent to the private IP address, but it's not like the same concept. It looked, you know, like the same concept, but it's different. it gets the IP address automatically. The link local address, it's auto-configured in your machine, okay? And it gets the global IP address from your router, okay? So in this case, also, your DHCP server, if you guys recall, becomes like optional. So you don't need sometimes the DHCP server to be in your network, by the way. That's another thing. You know, you can eliminate the DHCP server, or you can use them to assign IP version 6 to your machine. But if you don't want to use them, that's fine. The router will assign a global IP address to your machine. Okay. Also, as I said, I mean the link local IP address is auto-configured in your machine. So when your computer boots up, it will assign a local IP version 6 link local IP version 6. And then it will get the global IP address from the router. So we'll have a combination of link local to communicate locally and a global IP address that can get you out. That's all what you need in IP version 6. So simplicity, reliability, redundancy, and security. You get that? So, what we're going to talk about now,
Well, if you can just mention a few things about tunneling.
yeah,
Well,
that's
well,
tunneling.
okay.
Yeah, tunneling. Now we're talking about dual stack routers. That these router interface you can assign IP version 6 and IP version 4. So the router will understand and talk IP version 4 and IP version 6. Now for tunneling, for example, you have this router here, and you have this is a cloud of IP version 4. Okay. So we have this organization, they're still implementing IP version 4. And they want to communicate with another network here that already started implementing IP version 6. Okay? So how are we going to communicate? Okay, and we have here. This is the internet, for example. So the router here, what it will do, you will create a tunnel, okay, called for example, if you want to send a packet from here to IP version 6, the router will create a tunnel called 4 to 6 tunnel. It's a special configuration that you configure on the router that will understand your IP version 4 packet, okay, convert them and like tunnel them through the internet, okay, and go to the IP version 6. Now there's another kind of communications called or another tunneling called 6 to 4. That's vice versa. So another tunnel that encapsulate your IP version 6 into IP version 4 packets, and route it through IP version 4 cloud. Okay, and get it to the destination.
And the speed, does it make a difference if you use the tunneling or
No.
the router?
No, absolutely. It's going to be the same speed because configuring the tunnel, it has a lot of specifications and a lot of things that you can do to accelerate your communication. So it's not a problem.
Okay.
Bandwidth is not a problem with IP version 6 as well because, as I said, you save a lot of process cycles on your devices and your network, and the router and the switches, and also you're using anycast communications much faster even than multicasting in your network. So you're saving bandwidth by using IP version 6. Now, the last solution, NATing. Even if we needed to eliminate the NATing in your environment by implementing IP version 6, but in this case you just use the NAT device, which is usually a router, just to translate packets from IP version 4 network to IP version 6. So for example, if you have this node here, want to communicate with, here's the router or NATing device, want to communicate with IP version 6 network here. Okay, this is IP version 4. So what that NAT device does, build like a table Okay, IB version 4 mapping to IB version 6 IP addresses. So any packets go through that router, okay, it will be translated to either IP version 4 or IB version 6. So it does like translation to the packets. So if he gets, for example, this router, he's not configured for tunneling, he's not configured for dual tunnel, but he's configured for doing NATing, IB version 6 NATing. So once you get a packet that coming from IB version 4 node going to IB version 6, he will have a table. He usually maintains a table of IB version 4 to IB version 6. So okay, this is like 10.1.1.3. Okay, you want to communicate with another version, IB version 6 IP address, FE08, whatever, you know, long terminology for used for the IP version 6. So okay, then that one here, okay, that will be routed through this interface. So I'll route it to IP version 6. And the same thing happens when you communicate from IP version 6 to IP version 4. So it does like translation. So that's the third method that used to facilitate or ease the
Which one is the
transition.
most common one?
Well, the most common one is the tunneling and the dual stack routers.
And as
Some-
far as
that's-
cost, money?
Yes, yeah, because you don't have to like buy a special netting device or add more like features in the iOS or upgrade your iOS to be able to do netting on your network. So cost efficient method is, you know, just using tunneling, configuring tunneling in your routers to be able to communicate. Okay guys, so far
الله يعطيك العافية.
يعني I think we should be good for now. يعني